our first example. Let's take a look. So we're going to calculate this definite integral, and it's the integral from 0 to 1 of 2x times x squared plus 1 raised to the power 5. We're integrating with respect to x. And for this example, we're going to try method 1. So basically, we're going to go through the substitution rule process just like we normally would. And then the very last step, once we have our antiderivative back in terms of x, we'll go through the evaluation. All right, so let's see how this looks. So first step, we need to choose u and then calculate du. So there's a few ways to go about this. How do we pick u? We can kind of identify the more complicated piece here. So there's kind of two pieces of our function. There's this 2x right here, and then there's this more complicated piece of x squared plus 1 raised to the power 5. And so a lot of times what happens is with substitution rule, this complicated piece, we're looking at what's inside the parentheses, and that's our choice for u. So step 1, we're going to pick u equal to that x squared plus 1. So we see parentheses, the x squared plus 1 is inside the parentheses. That's our choice for u. It's kind of also this more complicated piece. That's where we're kind of focusing our attention here. All right, so once we choose u, then we calculate du. So derivative of x squared plus 1 is 2x, and then we multiply by our differential dx. And we're going to go through this definite integral, and what we want to look at is this kind of smaller piece here, this 2x. It's not necessary, but it can be helpful to just move that term next to the differential. Yeah, it's not absolutely necessary to do this, but if you find that you're having some difficulty, it helps. And the reason is because when we look, 2x dx matches up perfectly with what we calculated for du. So this 2x dx is going to become du. And then by our choice, this x squared plus 1 is going to become u. So we're going to have a u to the power 5 here. And that's by our choice of choosing u equal to x squared plus 1. All right, so that's the first step, is choosing u, calculating du, and then we plug all of these, we substitute in our values. So instead of the x squared plus 1 raised to the power 5, we're going to have u raised to the power 5. Instead of this 2x dx, we're going to have du. And to really emphasize that our limits of integration are going to stay the same, right now in this original definite integral, these are actually x equals 0 and x equals 1 because we're integrating in terms of x. So to emphasize that we're not switching over our limits of integration, we're going to leave these x equal to 0 to x equals 1. Also as a reminder that we need to make sure we convert back to x then once we have our antiderivative. All right, so we have our integral here. Now we find the antiderivative. This is something we can do. So that was step 2 in our work. Now we're going to go on to step 3, find the antiderivative. So this is power rule. So our variable is u. We add 1 to the exponent, so that takes us up to 6. Take that new exponent, flip it, put it in front. So we have a 1 over 6 there. And then because we're doing a definite integral, we want to make sure we now start writing the evaluate line. So this big vertical line at the end. And we put the lower limit on the bottom and the upper limit on the top. And we're using x equals 0 and x equals 1 just to remind ourselves that we haven't changed over the limits of integration. So that's step 3. And then step 4, convert back to the original variable. So instead of u, I'm going to plug back in my x squared plus 1. So instead of this u right here, I'm going to switch it over to x squared plus 1. So our antiderivative now, back in terms of x, is 1 over 6 times x squared plus 1 raised to the power 6. And we're going to evaluate this. So we have our evaluate line, and we're going from x equals 0 to x equals 1. And that was step 4. Convert back to the original variable. So once the limits variable on these limits of integration, and once the variable for your antiderivative, once they match, then we can start plugging in. So that's the last step. Just evaluate this like you normally would. And one little reminder, because we're doing a definite integral, we don't have to use plus c for our antiderivative. All right, so step 5 is let's do the evaluation. So the top number goes in first. So we get 1 over 6 times, and then we plug x equals 1 in. So when we plug x equals 1 into this, we get 1 squared plus 1, which is 2. So we get 2 raised to the power 6. And then we plug 0 in. And when we plug 0 into this, we get a 1 over 6 in front, but then we get 0 plus 1, so we get 1 raised to the power 6. And there we go. Whoops. And if we wanted to, we could simplify this down a little bit. And maybe the only thing we do here is 1 over 6 times 2 raised to the power 6 minus 1 over 6. Yeah, we could simplify that down further, but that's fine. We could stop there. All right, so that's really one of the ways to go about substitution rule for a definite integral. Just kind of go through the process like you normally would, leave the limits of integration alone, and it's helpful to write them as x equals 0 and x equals 1, or x equals here. So that's kind of an important thing to do. So we want to make sure we write x equals for our limits if we use this method. Because over here, if we didn't have the x equals, well then it would be confusing whether we're talking about u is equal to 0 or x is equal to 0. So you want to, if you're not going to switch the limits of integration, write x equals in front, just to really emphasize that you didn't switch over the limits of integration. And then just go through it like normal. All right, we'll try another one of these just to see how it's done, but we'll keep practicing. So we'll see you there for the next example.